Okay, hello everyone, I'm the reporter from and my topic is ring on a rod. So this is our problem statement. A washer on a vertical steel rod may start spinning instead of simply sliding down. And the main focus is that what determines the terminal velocity. because when it's spinning down, it will reach its terminal velocity. So here is our outline. We will first show you the phenomenon, and then it's the experiment setup, and then the theory and data analysis, and then it's the last, which is conclusion. So here is the video of phenomenon, and we can see that the ring will spin and spinning down in a spiral way. And this is our experiment setup. So we have 4 rings made of plastic and a steel rod. And so we spin the ring from the top of the rod, and it will reach its terminal velocity when during its rotating down to the bottom of the rod. So this is our experiment parameter. What we change in our experiment is the inner radius, and because when we change the inner radius, the outer radius will also change. And then what we didn't change in the experiment is the radius of the rod and the coefficient of friction. And it is because due to the limitation on the accessible resources. So here comes to our theory. So this is our first model of our theory, which has the x, y, z axis. And the most important thing here is the omega s and omega p, which is the angular velocity of spinning and precession. And R1 here is the inner radius of a ring, and RC is the distance between the center of the mass of a ring and the z-axis, which z-axis here is the rod. And that is inclination angle, which is theta. So this is our second model. So from the Euler angle, we can set a coordinate. We can set a coordinate on the center of the mass of the washer, which is the ring. And so we can define another 3 axes, which is 1, 2, and 3 axes. And then we see the precession of the ring as the rotation of the axis 1, 2, and 3. Then we can define that the omega p equal to the phi dot, which is the angular acceleration of this phi. And by calculating a little bit more, we can get the omega 1, 2, and 3. So the next I'm going to talk about torque. But before the torque, a very important thing is the angular acceleration. So we know that the angular acceleration alpha will equal to d omega dt, which omega is the total angular velocity in the theory. And after the calculation, we can get that the alpha equal to omega s, omega p sine theta on the z-axis, which means it's on the horizontal surface. And from the Euler angle, we can represent the z-axis by the E1 and E3. So we can expand the formula like this. So the next comes to the moment of inertia, and I won't mention too much here because we can find many information from the internet. So here comes to the torque. So from the Euler angle, we can know that the torque can represent like this, which we have tau 1, tau 2, tau 3 is the torque on the axis 1, 2, and 3. And then we bring the moment of inertia, angular acceleration, and angular velocity into the equation. And then we can get that tau 1 and tau 2 will equal to 0, and tau 3 will equal to the value here. So from the dynamics, we can also return the tau 3 as tau 3 equal to R1 cross Fk, which Fk here is the kinetic friction force. And because when the ring reaches its terminal velocity, its force should be equilibrium. So when it reaches terminal velocity, the Fk on the z-axis will equal to ng, which makes the Fk equal to ng divided by sine theta. And because we have 2 equations, both represent the tau 3, so we can calculate the equation here. So the next comes to the terminal velocity. So we have 2 diagrams here, and the first diagram, the brown circle is the ring, and so we know that the yellow dot, its velocity is R1 omega s, and the blue circle is the rod, and the orange point here the orange point here is the center of the mass of the ring. So omega p means that the angular velocity of precession. So we know that the velocity of the center of the mass of the ring will equal to RC omega p. But because terminal velocity is on the vertical axis, so we have to times sine theta and tangent theta to change its direction to vertical. And then is the derivation of RC, which is the distance between the center of the mass of the ring and the center of the mass of the rod. So here is the top view of our experiment. And the brown ellipse here is the ring from the top we see, and the blue circle is the rod. So we define that the center of the mass of the ring as the origin of coordinate, and R1 is on the x-axis and R1 cosine theta is on the y-axis. Then we can define two equations, which is the first is the equation of the ellipse of the ring, and the second is the equation of the circle of the rod. And because it has two reaching points, so we can make them into the simultaneous equation, and as, after the calculation we can find the RC. And because we get two equations, both represent the relationship between omega s and omega p. So the first equation we get from the tau 3, and the second equation we get from the terminal velocity. So after the calculation, we can calculate the omega p by all the known elements. So then, because we know that the terminal velocity equal to RC omega p tangent theta, and because we get everything we need in this equation, so we just plug them in and get the final equation. So here comes to the data analysis. The first is inclination angle. So instead of calculating the inclination angle based on the theory, we just photograph it and measure it from the tracker. And the table here is the inclination angle. So we have the inner radius from 0.61 to 1.01 centimeter. And the next is omega p. So here is the relationship between R1 and the angular velocity of the precession, and its error is very big, and we think it's because of the sliding caused by the kinetic friction. And here is how we find the terminal velocity. So we get this graph from the tracker, and we can see that when we start spinning it, its speed is small because its gradient is also small, and it will accelerate here and until it reaches its terminal velocity, which makes its gradient stay the same all the time. And so here is the relationship between the R1, which is inner radius, and the terminal velocity. So we can see that the error is still very large, and the reason is the same, is because the sliding caused by the friction force. So here comes to the correction of our theory. So because in our theory we didn't consider the sliding, so we will consider it here. So we know that when the ring reaches its terminal velocity, the loss of the gravity potential energy will equal to the negative work done by the kinetic friction, which we show here. And by doing a little more calculation, we can get at the sliding velocity on the z-axis and the sliding velocity on the x-axis. So here is how we modify our equation. So here, the equation here can represent how we consider the affection of sliding into the theory. So after our correction, we can see that the correction data and the experiment data is very close, which means that which proves that our correction is correct. and the terminal velocity is the same. And in this diagram, we can see that when R1, which is the inner radius, increase, the terminal velocity will also increase from here. So here comes to the conclusion. So the formula on here is our theoretical formula, and on the second line is the formula after the correction. So what determines the terminal velocity the most within is the inner radius, which is R1. And the second point is that in our theory, we have to use kinetic friction force instead of static friction. And the third is the error of the data is caused by the sliding, which because the kinetic friction. Thank you for your attention. This is the end of my.
Okay. Now, opponent has 2 minutes questions to the opponent.
The measure of height of the rod.
Height of the rod. I don't think that will affect our experiment.
Do you give the water initial integral velocity? Do you give the water initial integral velocity?
Yes, the spinning.
So you tilt the water.
No, we just spinning from the top of the rod.
And do you use the same initial velocity every time?
No, it won't affect the terminal velocity.
Why you won't affect?
Maybe we can.
Discuss it later.
Yeah.
Your rod vibration.
Oh, it's very small, so I think it won't really affect a lot.
What about the connect points?
We have show.
So you think it have 2 connect points?
Yeah, it have 2 connecting points because we can see it here. It has 2 connecting points.
Do you have another parameter for the rod?
For rod, no, because we don't do it in our experiment. Yeah.
What's the inclination angle?
Inclination angle is it's the angle here.
So the angle is always stable.
Yeah, it's stable.
It's stable.
It's yeah, it's stable.
And do you think the tilt angle will influence the terminal velocity?
You mean inclination angle?
Yes.
Yes, because it's in our theory.
So when you give it initial integral velocity, will the water?
Okay, time stop.
Thank you.
1 minute, 3 minutes, it's a good time.
number 3 ring and rod. And for the problem statement, it said that a washer on a vertical steel rod may start spinning instead of simply sliding down. And study the motion of a washer and investigate what determines the terminal velocity. And I think the main focus should be the motion of a washer and the center mass of a washer. And the parameter that influence the terminal velocity is also important. For overview of the reporter, for the observation part, he showed the phenomena and explanation and experiments it out. And for theory part, he used a model of the rod and model of inner angular system and angular acceleration and also moment of inertia and the torque analysis and terminal velocity and derivation. And for the experiment part, the variable is only the inner radius and the outer radius. Doesn't change the rod's parameter. And the conclusion is the inner radius is a dominant reason which causes the terminal velocity. And the kinetic friction instead of static friction. And arrow is the sliding caused by kinetic energy. And the point, the prose is fluent English and clear diagram and explain the theory very well. And suggestion and cons is lack of a combination of the theory and the data, and lack of a parameter of the experiment. And we suggest that the reporter should also be briefly talk about the theory, even though it is on the internet. And for discussion part, I will discuss about the connect points. Maybe it will have two situations. The first situation is it will have one connect point, and the second situation is it have two connect points. And also we will discuss about moments of inertia and the center mass of the washer, the motion of it. And also the vibration of a rod, I think it will influence the terminal velocity a lot, and also the tilt angle and the reference between the initial angular velocity and the terminal velocity. And also we will discuss the revolution and rotation of angular velocity, what's the relationship between them. And now I will go to the discussion part. Thank you. Can you talk about what's the influence of the rod vibration?
Okay, so so we can see here when it starts to spin around town, its vibration is very small that you can ignore it because it reaches its terminal velocity when the time increases. So it's not from the 0 second and it's the terminal velocity.
So you don't think the vibration will influence a lot?
No, I don't think that influences a lot.
So your rod isn't a regular vibration? You find it regular?
Maybe it's a damping vibration or something, but I don't think that really affect our experiment.
Just think about the rod will do a circular motion.
Rod do a circular motion. Yeah, the rod is very stable when the ring goes to the maybe the middle, and it's very stable when we see from the top.
I want to know why don't you consider the height of your rod?
Because we have to know. Okay, so maybe we will. So if the rod is long, and maybe it starts to spin and it reaches terminal velocity here, maybe. And another is the rod is short, like maybe like this. It still reaches terminal velocity.
So you mean it will reach the terminal velocity at the same place?
Yeah. Because the length of the rod won't affect the terminal velocity.
But I think the length
The length of the rod? Why? Can you explain?
because if the length is long enough, and I think the terminal velocity will be bigger because of friction force.
No, the terminal velocity is static value. So if the rod is longer and the terminal velocity go bigger, is that what you mean? I don't think that is correct because in our theory there is no the. So in our theory we didn't consider it at all because.
Okay, I get your point. And for next question, and what do you think the connect point is a tool?
We have the.
Do you think about it's related to the radius of a washer and radius of a rod?
Okay, so because so if this is a rod and this will be the washer.
So the connect point is always a 2 points
Yeah,
in
will,
every situation,
yeah, and in every situation.
no matter the radius of a.
Okay, so maybe if the washer is very big, maybe it will be one connecting point because if the washer is very big, maybe like this, and maybe it will look like one.
Just one connect point.
Yeah.
And do you think there, what's the difference between the 2 connect point and 1 connect point? Will it influence the terminal velocity a lot?
Yeah, so if it is one connecting point, maybe it will be steady friction, maybe because you have to rotate.
And what about the 2 connect point? It also rotates.
Yeah, but it will be the kinetic friction because it won't. So it has 2 connecting point maybe here and here, so it cannot be the
So
steady friction.
will it rotate?
Yes, it will rotate.
It will rotate, and also it will slide.
Yeah, rotate and sliding can happen together.
And what about the only 1 connect point? Will it sliding?
I think it won't because
So I also think it will. Do you have any?
because if it's one connecting point, I think it will be rolling maybe.
Rolling?
Yeah.
Do you mean the pure rolling? Rolling.
Just rolling.
Just rolling.
Which is
Will it
the
tiles and also rotate?
rotate and rolling can.
So will it tile? Tiles.
You
Not
mean
liquid. The water.
the one?
Or tiles. Tiles. Liquid.
Yeah, it will have inclination angle.
So the the tiles angle when 2 connect point and 1 connect point, what will have the influence?
Okay, so if it is one connecting point, it maybe looks like this, maybe. Yeah. But if it is 2 connecting point in our model, it looks like this. So the connection point is here and here. And this is the maybe the right side view of the experiment, and if we see it from the front view, it will look like this.
What about the motion of the center mass of the water?
Center
Mass of the water.
mass.
It will rotate around the water.
Yeah, because it has a precession angular velocity.
Oh, for the precession and the revolution.
Precession is
Precession and the rotation and
it has the precession and spinning.
precision.
Yeah.
And is there any relationship between their angular velocity?
Yeah. Precession is one kind of angular velocity.
And speed.
Okay, so
These 2 angular velocity.
okay, you mean the relationship?
Yes. Which
So
one is the bigger one?
bigger one is the what do you mean the bigger one? You mean
The angular velocity of the washer rotates. And the central mass of the washer rotates. Which angular velocity is the bigger?
it is the precession one. Yeah. Because the faster it spin, the precession. So if it spins faster, the precession will be small. But if the spin is the spinning velocity is small, then the precession angular velocity will be bigger.
So do you think about the rotation angular velocity will influence the terminal velocity?
Yeah, it is in our
So
equation.
when it's bigger and the terminal velocity will be bigger.
Yeah. So we show it here.
And why do you only use the parameter of the rate?
Because we have a limitation of the resources.
And how can you improve your parameter that you can do in the rod?
Okay, so maybe we will change the diameter of the rod and
Maybe loopiness of the rod.
roughness. And I think if we change the roughness of the rod, it will change the kinetic friction coefficient. And because the friction
And
will.
if we change the loopiness of a rod, will the motion is the same or not?
Okay, so the motion will be the same, but the affection of sliding won't be the same.
So you mean that the loopiness of the rod will only influence the velocity figure?
And it won't change the theory here, but it will change. It will change the affection of here. Yeah, because it's the correction from the sliding.
And I would like to put the height of the rod again. And
Okay.
what do you think about the place that the washer reach the terminal velocity, but the height is the same?
Because
I think it's the same.
so because we know that when you start spinning, okay, so we know that the velocity will equal to where P times the RC, yeah, and maybe have the tendency here, and because the friction force will equal to.
So you think it's all influenced by friction force?
Yeah, because the force dependence by the velocity, I think it is the friction force.
What about the rod is very, very fast? And will you consider the air resistance?
Air resistance.
It is very fast.
The air resistance is very small, so I don't think we have to consider it in our experiment.
So you see the height won't affect the experiment?
Yeah, the height won't affect. Do you mean
the height of the rod, it will change its motion.
you mean the rod will vibrate?
Yes. The vibration.
So I don't think it really changed because it is steady.
Okay, thank you.
Time's up. I have 1 minute to summarize and discussion.
And we discussed about the connect point and also the sentiments of a washer and the vibration of a rod, and also discuss the initial angular velocity. And so what determines the terminal velocity? And about rod vibration, it will influence the experiment. And the reporter said it could be ignored. However, we think the rod will have a vertical effect to the experiment. And why not consider the height of a rod? And I think the terminal velocity will be bigger because of the friction. And the contact point, and we agree with the reporter, it will be one contact point because the shape of the washer is circle. And this one is rolling and rotating, and the reporter said it will only rotating, and we think it also rotating. And thank you.
Good evening. Let me start my question for the reporter now. And you have been constantly calculating the terminal velocity of the washer, but have you ever considered why is there a terminal velocity of the washer?
Yeah, because it has the force dependence on the velocity, which is the Fk.
Okay. Now the next question. Do you think that it will be a 1 contact point or 2 contact point or even 0 contact point when it reaches its terminal velocity?
So from our experiment, it is 2 connecting points.
2 contact points from your experience.
Yeah.
Okay. Now, and the next question is: have you ever considered that the coefficient of friction may affect the phenomenon?
Yeah.
Or, okay.
Affect the sliding.
Now, what about mass?
Mass will also affect the sliding, but we didn't consider it in the theory.
What do you think, the opponent? Do you think that mass should be considered?
Yes.
So you think that mass? Okay. Now, the next question. Do you think that the center mass of the washer will be changing in the phenomenon?
No.
No, the center mass is always the same.
Only
in
the
place?
washer? You mean only the washer
Yeah,
or
the
the
wa-
system?
The washer.
No.
No, so it will stay in the same place even if it descends?
No, I mean, because we set the origin of coordinate on the washer.
Okay, now, if the origin is on the ground, so will the center mass change?
Yeah.
Yeah, so it will waggle around the
Yeah.
ground, right? So if it will waggle, so it means that it will have the vertical and the horizontal waggling on the phenomenon. So how can you analyze the motion of the center of mass?
We have the precession.
Yeah, but the precession is not enough because it has
Yeah,
vertical
we
and
also have the
horizontal.
zero angle, and we have omega 1, omega 2, and omega 3. And
Oh, so you think that is sufficient enough? Okay, so and now the next question: do you think that if the rod is threaded or it is a smooth rod will affect the phenomenon?
Yeah, because it will affect the sliding.
And did you put it in your conclusion?
I put it in our correction.
Oh, thank you. And the next question: do you think that nutation is a factor here? Nutation, the oscillation of the precession. The precession is like that, and it will like.
No, the
Yeah.
precession is static.
Do you think the nutation is a factor here? That the precession will have a oscillation effect?
Yes.
Yes. So the opponent thinks that it is a factor here. Now, if you mentioned that you change the radius of the washer. So when you change the radius, will it affect the mass of the washer?
Yeah, but it will only consider the mass will only consider in a correction. So in our theory, it won't affect. But
Okay. Now the last question: do you think that it is a sliding or spinning?
sliding.
Sliding. Only sliding.
Both sliding and rotation.
Both sliding and rotation.
Yeah.
Okay. So
Thanks a lot.
thank you.
Okay, next up,
Good evening, everyone. I am the reviewer in the question. I'll be reviewing this topic ring on the rod. Now, the problem statement I will now restate it again. Our focus on the motion of the washer and the center mass and the parameters affecting terminal velocity. Now, the reporter said that when the washer is put on the rod, it will wag up and rotate down. The theory is their Euler angle system, energy conservation, and the experiment is different radius of the washer. Their strengths are they made some clear models and great diagrams, and their weaknesses are lack of intuitive explanation of the cause of terminal velocity, omitted the effect of the moment of inertia. They didn't consider the moving of the washer that may cause the rod to tilt, and they are unsure of their theory. And next one is the opponent. They had made a great summary in their presentation. They pointed out some points that the report missed, but they didn't mention some key points that we think that should be considered. Now for discussion, opponent asks, influence of vibration of washer, the report said no influence, but the rod is stable. The reviewer agrees with the opponent that it should be considered. Now is the counterpoint. And as we have asked that before, so we will not restate it again. Now the opponent asks the motion of the center mass, and the reviewer said if per section is small, then spin will increase. And the reviewer would like to suggest that the reporter using the Fourier transform analysis of the motion to analyze the vertical and the horizontal motion of the center mass. Now the next one is the roughness of the wall, and the reviewer thinks that it has an influence on the phenomenon, but the reviewer did not take it into consideration, so that is a bad point for you. And now the points missed. The reviewer thinks that according to the purpose statement, there is a terminal velocity to be found in the purpose statement, but they haven't elaborated on why is there an existence of their terminal velocity. So we think that it should be considered. Now, the next one is the ring mainly rotating or sliding, and why is the reason. They have said that they think that it's mainly sliding on the rod, but they have not elaborated on the reason why is the phenomenon like that, right? And the next one is the counterpoint after reaching the terminal velocity. They say that the reporter stated that they had observed that there are two contact points, but they didn't mention why is there only two contact points, or why is there two instead of one. And the next one is how do you stabilize the rod to eliminate any vibration? Since when the washer is spinning, it may transfer some part of its energy into the rod, and the rod may tilt. But they just stated that their rod is stable and didn't consider that. The next one is why shouldn't air resistance be considered, since there definitely should be air in their system, so it should be considered, even if the effect is minimal. The effect of collision and friction and mass. We think that the mass of the washer should be considered in their experiment. And the next one is when they change the radius of their washer, it definitely will change the mass of the washer. So that is another reason that they should consider. The next one is the nutation factor. So we do think that nutation is a factor here. So the precession of the washer will oscillate. Now the next one is the wobbling of the washer, which they have made some explanation on it, but didn't elaborate on it throughout. The next one is a observation method, which it is if you look at something, you will see two dots. But if you change your point of view, it will cause some difference in your observation. So that is something that you should consider. And the last one is we suggest that you use slow motion to observe the phenomenon more clearly. And thank you, everyone. That's my review.
Okay, so here is the remark of the report. So the first question is that is the effect of the vibration of the rod, and we didn't consider it in our experiment because the vibration is very small. And then the second question is it 2 or 1 connecting point? And our connecting point is 2 points. Yeah. And the third question is that do you think which angular velocity will be the spinning angular velocity will be bigger, and the spinning angular velocity or the precession angular velocity will be bigger. So we have written it in our theory. And the next question is that do you think the height of the rod affects the terminal velocity, and we don't really think that will affect. So here is the conclusion. So the opponent do hold many interesting points that we didn't consider. But however, the opponent tends to grasp on the question that wouldn't affect the result very much. And second is during the discussion, the opponent clarified some of her misunderstanding. And then the opponent also did raise something interesting aspect. And that is the review also. So the review also did raise insightful points, but ask some trivial questions that are answered in the presentation. Thank you.
Okay. The rest have any questions?
Okay. I have a question for the reporter. So you have a theory and you have an experiment. How well do they match? I think you showed some slides with the matching between theory and experiment, but I didn't see clearly. Can you show again?
You mean the correction here?
So, I don't know. No, I mean, you have numbers from the theory and numbers from experiments, right?
Yeah, because it's the correction. So it's not our theory, it's the correction. So here, the error is because of the sliding.
What are the points?
So it is the terminal velocity and
which one is theory and which one is experiment?
The blue one is theory and the orange one is experiment.
And you have error bar for the observation.
Yeah, because we do the experiment about 10 times, so we will have
so
the
they
error
don't
bar.
really match, right?
Yes.
Yeah, because it is before the correction.
Oh, so after the correction.
Yeah, after the correction, it measures a lot.
So this is. Can you say again?
So the y-axis here is the terminal velocity, and the x-axis is the inner radius. And we can see that it matches the experiment data and the data after the correction match a lot.
Okay, thank you.
Have any other question?
Okay. So when you put the washer on the rod, do you spin it?
Yeah, because we have to spin it to make it have a cross-section.
So do you know do you think the spin, like the angular velocity would change your terminal velocity?
No, because the terminal velocity is decided by the friction force, and so it means it will reach the entry on the normal force. Yeah.
May I answer the question?
Yep.
If we give the washer an initial angular velocity, and it will cause it have a terminal velocity. But if we give it non-linear initial angular velocity, and the washer will crush the rod, and the xt diagram won't be it won't cause the terminal velocity.
Any more question?
I have one question for the reporter. In a free fall status, so if we have free fall status, then for the 2 contact points and 1 contact point, which one could have a higher possibility so that the washer could spin?
I think it's the 2 connecting points.
How about you, opponent?
I think 1 connect point.
1? Okay. And how about you?
We think that
Free fall.
maybe 2 contact points will be optimal.
Thank you.
Okay. Any question? Please give the score. Okay, now give me the reporter score. 87677.
Thank you.
Now give me the component score. 77776. Reviewer. 88887. Thank you.
Thank you, everyone.
We finish this batch.